Okay, I've come up with a new kind of spectrometer. It's basically a quantum heat or radio low quality uh, spectrum analyzer of electron frequencies, but it does it with a three-dimensional chip. Its heat signatures or radio waves or whatever, photo photo signal, photon signal, three-dimensional wavotorium. Okay, it can do it with different sources of photon radiation or electromagnetic radiation. So this is a three-dimensional electromagnetic radiation sensor. Okay, we have our data here. I have an Arduino with a big piece of ferrous wire coming out of an ADC, reading at 15K per second. Okay, you see the last three that's constant at the end next to the send, right below the E. Okay, it stays that way. But if I light this lighter, at the right position, it changes. And it changes at different distances. So if you could create a microchip that was a cube of thin atomic wires, 1 atom thick, that were cubic, and every tiny, maybe it doesn't have to be 1 atom thick, but however the width of a radio wave or a photon wave is, like the wave height, the wave height is how thick you want the wires to be, but you stretch all these wires into a cube and call it a wavotorium. Well, at the different distances, the three will change. Those threes, see, I'm changing it now with the lighter by moving it back and forth, and that signifies it goes right back when I move the lighter out. We got a constant flow, okay? But when I change the energy levels, it changes. So it would basically be like a photon signature, okay? You put a certain amount of volume of energy into a polymer structure, and you focus in a vacuum that electromagnetic signature that is directly in line with a cubic wavotorium chip, and you get this. Basically, you get these variable endpoints, and the energy is flowing through it at different distances. So each atom that is producing energy will produce it through the length of the wavotorium at different forces. You separate these wires in this cubic wavotorium chip, and you get each and every signature from the electrons that are potentially transmitting energy to the wavotorium. You get a signature that is actually an electromagnetic identity of the motion of energy transmitted to an atom that is probably unique to each kind of atom. Unique electromagnetic radiation identity in this wavotorium cubical signature. Okay, this is my invention, and I think it will work. But you need the wavotorium chip. It has to be designed into a cube. And then you have to absorb and test, and you have to have high throughput electronics. And basically, you get each frequency and each voltage and amperage through low amounts of energy that can transmit low frequency radiation into a sensitive conductive wavotorium chip, and voila, you have a signature that is varied based on how close you are to it. By Leonard Dance Jr., December the 16th, 2020.